All right, guys, welcome to Miss Lastly and Miss Markert's day number 4. Today we're just going to do some mixed sequences. So just doing a little bit of practice. There's no real notes today, just can you identify which one is going to be arithmetic versus geometric when they're all mushed together? All right, take it away, Miss Markert.
So I'm just gonna go through, I think, the first two and let you guys do the rest on your own for today. So yeah, I guess we're gonna jump right in. I'm making geometric sequence blue and purple ones, the arithmetic sequences, just because I like to color code things. So, that first one, let's figure out which one that would be. So when we're looking at the pattern, there's no real consistent adding anything to get the next term. So the difference between 27 and 36 isn't the same as the difference between 36 and 48. So I'm assuming that it's a geometric sequence. To find out what our R is, so our common difference, let's divide the second term by the first term. So let's do, so R is equal to 36 divided by 27. And then of course we have to simplify. So I'm just gonna let my computer do, it's 4/3. So this is 4/3 when you simplify it, and that is our common difference. And we can see that it's a geometric sequence. So then we're asked to find the explicit equation. So let's find that really quick. So our explicit equation would be AN. And then our first term, so our first term is 27. And then we multiply by R, so 4/3, and then 4/3 to the n minus 1. And there's our explicit equation from yesterday. And then we're asked to find what A10 would be. So to do that, we're going to take A10, and that's equal to our explicit equation. And for n, we're going to sub in 10 because that's the term number that we want. And that's going to simplify down to 27 times 4/3 to the 9th. And that is equal to 359.6 when you plug it into your calculator. And then the last thing that we're asked to do is find the number for the given AN value. So our given AN value is this big number up here. And so remember, this is just working backwards. So we're going to take that and we're going to plug that in for AN. So we're going to take 84990.0219, and we're going to set that equal to 27 4/3 and minus 1. The first thing we need to do is divide by 27. And that gives us 31462.593. Big long decimals. And then we still have this exponent over here. So remember, when you're solving equations that have exponents in them, this becomes a log rule problem kind of, because you have to switch it over to the log. So we're going to use our log rules and we're going to finish solving the equation. So then this becomes n minus 1 equals log base 4/3. And remember, on your calculator, if you have, I think it's one of the newer ones, it's Math Alpha Math, to use your change of base formula on your calculator. Yep. If you don't have a newer one, there's a change of base formula you can use. It's just more annoying. And then instead of rewriting out this huge long thing, that's going in right there. And then you can just plug that whole thing into your calculator, and we get 36 is equal to n minus 1. So our AN value was 37 for that number. Let me move this just a little bit. Okay. So then for number 2, looking at this sequence, when I look at this, I see that 27 to 31, that's a +4. 31 to 35 is a +4. This is also a +4, so this must be an arithmetic sequence because we are adding a common difference every time to get the next term. So this is an arithmetic sequence. So our explicit equation for this one would be an equals the first term plus 4 times n minus 1. And remember, 4 is our common difference, and that just goes in there. And then we're asked to find a10 again for this one. So we have a10 is equal to 4 times 10. Oops, sorry. I simplified my equation and didn't, forgot to show you guys that. So we're just going to simplify this really quick. So when this simplifies down to 4n plus 23, and that makes it just a little bit easier to work with. You don't have to simplify, I don't really care, but that's the simplified one if you want it. So then 4 times 10 plus 23, this is equal to 40 plus 23, which is equal to 63. So our a10 is 63. And then our next thing that we have to find is what term 783 is. So remember, this is, again, a working backwards problem. So we're going to take 783, and we're going to set that equal to our explicit equation. So 4n plus 23. And then we're just going to solve for n. So we're going to do minus 23, and that is equal to 7. Sorry guys, dishwasher is done apparently if you hear the beeping in the background. 760 is equal to 4n. And then we're going to divide by 4, and n is equal to 190. Just like that.
All right, looks good. So I think that is it for today's video. Yeah, hopefully you guys don't have any difficulties on today's homework. It's just a bunch of practice from the geometric and arithmetic sequences that we've been working on. All right, so until next time, bye guys.